y. The change in x is dx, and the dy here is the approximately equal to the change in y. Okay, the change in y is the delta y. The small change in x is the delta x, and which is the same as the dx. Differential x and delta x are the same, but the differential y and delta y, they are not the same. We use it as an approximation. So this is how to explain the notation dy, which is the derivative times dx. And again, don't get confused or get lost. Just start with the dy by dx, which is the derivative. Therefore, the differential is the derivative multiplied by dx. What you have to do in addition to find the derivative is multiply the derivative by dx, and then you're going to get the differential y, which is the main goal of this problem. Your goal is to find dy, which is the differential y. Okay, it's called differential y. You're going to find dy where f of x is provided. So starting with, for the first one, the f of x is e to the 2x. Therefore, the f prime, using the chain rule, we get e to the 2x multiplied by the derivative of the 2x, which is 2. Or we can rewrite it as 2 times e to the 2x. After you get the derivative, so then the differential y is the derivative multiplied by dx. That's the answer. And this is the relationship between the small change in x and the change in y related to the derivative. So the derivative, if you think about the meaning of the derivative is the rate of change. The rate of change, the change in y and the change in x. So it always come back as a cycle, as a the circle, as a loop. You're starting from derivative as a rate of change, and now we use derivative in different way in different applications, and it's gonna reflect it back to the original concept of it. All right. So the next one, number 2, f of x is sine square x, which is the same as sine x quantity squared. Okay, when we get into this format, it's easier to think about what rule we're going to apply and how do we find the derivative. So the derivative of this function, using the chain rule again, because we have the composite function, the inner is sine x, the outer is the power 2. So derivative of the outer, which is power 2, so 2 times the quantity inside, which is sine x, to the first power, multiplied by the derivative of the inner, which is the cosine x. We get the derivative. So we get the next, the differential y is the f prime multiplied by dx, or 2 sine x cosine x as a derivative multiplied by dx, and that's the answer. To use a quotient rule to find the derivative, I avoid f and g version because the function notation already in f, so I use u and v. The top u, the bottom v, so v u prime minus u v prime over v squared to get real quick, so 4 minus x times the u prime, which is 1, minus u or 4 plus x times the v prime, which is negative 1, divided by v squared or 4 minus x quantity squared. Simplify the numerator as 4 minus x, negative negative becomes positive, x negative x cancel. So then we get the numerator as 4 plus 4 or 8. Give you the differential y as the derivative multiplied by dx. The derivative is 8 over quantity 4 minus x squared, then multiplied by dx. F of x as natural log 3 minus x squared. So the f prime, the outer is the natural log The inner is 3 minus x squared, starting with the derivative of the outer, which is 1 over the quantity behind the log, and then multiply by the derivative of the inner, which is negative 2x. Then we get negative 2x over 3 minus x squared for the derivative. Then the differential y is the f prime multiplied by dx, or negative 2x divided by 3 minus x squared multiplied by dx as a differential y. And this one, as we recall, the dy is 8 over 4 minus x quantity square with respect to x, because the f prime is 8 over 4 minus x quantity squared.